Continuing on with 6-1, exponents, we have some problems now that involve variables and exponents. So you have to know the rules before we can try to attempt to solve this. Now the rules, if you're multiplying this with the same base, your exponents can be added together. So you can do x4 plus x over 6, and that is what happens if you multiply them together. The exponents add up. The other side remains unchanged. All right, now if you notice they have the same base. If this is an equation and the base is already the same, the only thing we have to focus now on is the exponents. So now our attention goes from the 2's, which we're done with, they're already the same, to making these the same. How do you write that? X over 4 plus x over 6 equals 3. So that becomes our new problem. We're going to solve for x using this equation. Now, when we're adding fractions with different denominators, we want to make sure they're the same. So 4 and 6, 4 can turn into 12 and 6 can turn into 12, but I'm going to multiply them by different numbers. I'm going to multiply this one by 3 and this one by 2. Whatever you do to the bottom, you do to the top. So my problem looks like this: 3x over 12 plus 2x over 12 equals 3. You can add this up. So we get 5x over 12 equals 3. Okay, to solve for x now, I have to get rid of the fraction. If you guys remember the rules of inverse operations, the inverse of this fraction would be 12 over 5. That cancels out the fraction, but it leaves the x alone. And on this side, we multiply it, 12 over 5, and we get 36, 3 times 12, over 5, and that is our answer. I guess if we also divide that, that would be 7.2. So fraction answer, decimal answer for x. Okay. Now there's a lot of steps, but basically it's the rules of fractions. Here, what if the bases are not the same? You have to make the bases the same. So you notice this is a 4, this is 256. The easiest way to do this is to take the bigger number and figure out how to make that into a 4. What do I mean by that? Well, 4 to the 1 power is 4. And usually what they'll do for these problems is they'll choose a number that is a multiple of 4. 4 to the second power is 16, because 4 times 4 is 16. 4 to the third power is 64. 4 to the fourth power is 256. So in these problems, generally they'll give you the smaller number, and your job is to turn that bigger number into a 4 using exponents. So I'm going to change this. Instead of 256, 4 to the 4. Everything else stays the same. Everything else stays the same. All right, but now I have an exponent and another exponent outside. Well, you got to multiply this. So what this means is the 4 is going to multiply x plus 2. Over here, there's nothing to multiply. So these are your exponents. Now, what about the 4's? Well, remember how in the last problem up here, I didn't worry about the 2's because they were the same? This is the same situation here. I'm not worrying about the 4, the big number 4, because they're already the same number. What is not the same are the exponents. So now my focus shifts to the exponents. So I distribute, I get 4x plus 8 equals 3x plus 9. I have to solve for x. I'm going to move, using inverse operations, I'm going to move this 8 over here and this 3x over here. And what I get is 1x equals 1. So my answer for x is 1. You could plug it in and basically double check this if you wanted to using a calculator. What you would say is, okay, 256, 1 plus 2 to the third power equals 3 times 1 to the 12th power. So 256 to the third power is the same value as 4 to the 12th power. They will give you the same number. That's what that means. Okay, next. All right, dealing with the fractions. I don't want to deal with fractions. And what they generally want you to use is the negative exponent. So if you guys remember, I told you, oh, this would be a to the negative 1. This would be 4 to the negative 1. That is how you can turn a number into a fraction with exponents, but there are different bases. And 4 to the second power, if I write this down, move this over, 4 to the second power is 16. It's not 8. So I can't use 4. So in this case, I'm going to change them both. This is 2 to the second power. So another way to write this is 2 to the negative second power. That would move this 2 to the bottom and square it like that. This would be 2 to the negative third power. And if you don't believe me still, watch this. That would turn into a fraction. That would turn into a fraction. 2 times 2 times 2 is 8. 2 times 2 is 4. And there you go. This and this are the same. This and this are the same. So I can switch out this fraction with 2 to the negative 3, and I can switch out this fraction with 2 to the negative 2. This problem will then change to 2 to the negative 3, and over here it'll change 2 to the negative 2. And now we have the same base, which means you are left to deal with your exponents. Your exponents are what's left to deal with. So here we have a negative 3 that's going to multiply x over 2 minus 1. And here we have negative 2 that has to multiply x over 3. So I'm going to wait right here to give you some time to solve this one. And then we'll get back to the next example, okay? So quick little pause, and then we'll go on to the next example. All right, I hope that was enough time. Now, some geometry problems. We're going to deal with squares, and then in a second we're going to deal with cubes, okay? Now, squares means we're using the powers of 2. So a number to the second power, okay? Cubes mean we're taking numbers to the third power, cubed, okay? So we're using exponents. Now, they want us to solve for x. Now, these two shapes are squares. This is a rectangle, all right? We're supposed to use the information from the shapes to find out what x is. Now, this is a little weird. Because this is a square, you can find the side by taking the square root. If you take the square root of this number, you'll get the side of the square. So you need to take the square root of 8, and the square root of 8, and the square root of 8. That's the sides of this square. Because this one is not a square, this is actually a rectangle, you can't do that. You can't do that with a rectangle. But this is supposed to be a square, so you can take the square root of x. So this would be the square root of x, and this would be the square root of x. If this is the area, the sides would be square root of x, square root of x. Okay? Now, that means for this rectangle, this side would be the square root of 8 right here to right here, and then this side over here would be the square root of x, because they're the same length as over there. So your problem is actually this: the square root of x times the square root of 8 equals 12. That's the problem. That's what we're doing. Now, if you multiply square roots, you actually get this, the square root of 8x. They just combine because they're both square roots. Now, to solve this, though, we're going to have to turn it into a fraction exponent. So, this problem becomes 8x to the 1/2, 12. Because remember how square roots come from this exponent? 1/2 is a square root. Now, to get rid of this, we're going to use exponents. Now, guess what the opposite exponent is of 1/2? 2. If you multiply 1/2 times 2, remember, put it over 1, they actually cancel out. And whatever you do to one side, you do to the other. Wait, but there's no exponent over here. There is. If you don't see an exponent, you could just put a 1 right there. And now whatever you did to one side, you also did to the other. So this now has a power of 2. This over here, the exponents canceled out. You're left with 8x. Okay, well, 12 to the second power is 12 times 12. That would be 144. To solve for x, you're going to divide by 8. X equals 18. 144 divided by 8. Okay, last one, the cubed, or the cubes. This problem's a little tricky because they give you the volume. Now imagine this cube is a water tank, like a fish tank. It's a cube tank. This has inside 3 meters cube of water. That's how much water is inside. That's called the volume. Now, this is what's weird here. The volume here is going to naturally be bigger than that. The question is how much bigger? Because the one piece of information they give us is that this side is half the size of this. So this tank is double the size, double the length, double the width of this one. So the volume is going to increase by 2, but how many 2's will it increase by? All right, so this becomes the problem. All right, now this might seem a little weird at first, but we're going to talk about ratios, okay? Because we know that one side is double the other side, the way I treat this is I try to find the dimension of this. Okay, here's what I mean. If you're looking for the volume of a cube, you're taking the side and multiplying it times another side and times another side. So it's side times side times side, or side cubed, which is why we have the power of 3 here. Now, when I take that side and I cube it, my volume is 2. Well, if I want to solve for that, I have to get rid of the cube. How do you get rid of this? With another exponent. What exponent will get rid of that? 1/3. 1/3 will cancel that out, but now I have to put a 1/3 here. Remember, you just multiply that by 1. So what does that do to my problem? The side is 2 to the 1/3. Wait, what does 2 to the 1/3 even mean? Well, if your exponent is a fraction, that means it is the cube root of 2. That is my side, the cube root of 2. All right, now, if I know this is the side, I can plug in this information right here. If you know that that side is double this, 2 times cube root of 2, that's the side here. The volume is what happens when you multiply this times this times this. Side times side times side, 3 times. So if you multiply this, you would have to multiply it to the 3rd power or multiply it 3 times. You're multiplying it side times side times side. That'll give you the volume. All right, now these numbers are roots. The 2's on the outside are regular 2's. So 2 times 2 times 2, that's 8. Cube root 2 times 2 times 2 is also 8, but inside. So you can't multiply a root number with a regular number. The numbers inside the cube roots can multiply, and the numbers outside the cube roots can multiply. And this is the volume of that. Oh, wait a minute. 8 has a cube root. The cube root of 8 is 2. Put that in your calculator. All right. So the volume is 8 times 2. What could that be? Well, 8 times 2 is 16. But wait, I thought the volume was this. 2 to the x. You're right. How many 2's would it take to make 16? How many 2's would it take? How many 2's would you have to multiply? Use exponents to get 16. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So the answer to this, the answer for the x is 4. 2 times 2 times 2 times 2. And that's the answer.